Hello and welcome to section 4.14, where we're going to talk a little bit about cis-trans isomerism in cyclohexanes. This is kind of the start of a new type of vocabulary that we're going to be learning a lot more about in chapter 15, and that is what a stereoisomer even is. So a stereoisomer is a molecule capable, well, really, we can say two molecules are stereoisomers if they have similar connectivity, but they are spatially, or but they are spatially different than each other. So that might sound like a really weird definition, but I'm about to show you exactly what that means. And to do that, we're going to learn about a new type of way to draw molecules or to think about them. And that's called using a Hayward projection, named for the person who invented it. So in the Hayward projection, essentially what you have is you kind of draw the 2D structure in a way that tries to convey 3D connectivity. So you see that each of these are like a wedge that I'm drawing. They're trying to show that this part of the ring is coming out at you. And then we have the back three. Oh, that is very bad. Let's try it again, shall we? So here are the back three. There we go. And so then the front three look like this. So there's the front one. And this is really just a rectangle, right? And the back one. There we go. Okay, that looks a little better. So hopefully you can see now that this front edge is supposed to be coming out at you. And so then in a Hayward projection, what you do is that you draw wedges and dashes as just pointing up for wedges. So these are where wedges typically are. Or for dashes going down. So doing this, we can now talk about stereoisomers using a very specific example here. So here's another Hayward projection. Oh, sorry. There we go. Okay, so if we had this molecule, the CH3 here is on a wedge, right? And the CH3 on the bottom, or CH3 on top in blue is on a wedge, and the CH3 on bottom is on a dash. Well, is that molecule different now from this one? Whoops. Getting crazy. There we are. So now these two molecules technically have the same formula, and also technically each of the substituent carbons there are attached to the same carbons on the ring, right? However, it's clear that these two are not identical because using the Hayward projection, we now see that the wedges and dashes are different for each, right? So that's what makes these stereoisomers. They have the same connectivity between carbons, but they have different spatial arrangements. And we would call the type of molecule where one substituent is up and one is down, we would call that, let me take this one because the font is bigger. There we are. Oh, okay. Come on. Control. There we go. There we go. Okay. We would call that the trans isomer because they are on different sides of the projection there. And the other one, where they're on the same side, we would call that the cis isomer. And this is what's meant by cis-trans stereoisomerism. And this has been section 4.14.